Welcome everyone. Today I am taking up one of the most debatable topic, angular velocity or speed versus angular frequency. When I say debatable, the reason is a lot of misinformations available on internet, Wikipedia, AI, it could be Google or anything. Again, then we are talking about a YouTube online classes, Facebook classes, a lot of misinformation. I cannot add everything, but I'll actually show some of them. Now, first and foremost thing, when we talk about angular velocity and angular frequency, these are like apples and oranges. There is no correlation between them. They are completely different things to talk in one single context. Okay, so first let's understand conceptually what they are, and then we will actually jump into how they are calculated as same, why there is so much of confusion on all those things. So when we talk about angular velocity is something that is for a motion in a curved path. Okay, so let's say this is my curved path, which actually has a radius of curvature. Let's say for this small portion, this is the radius of curvature. So at a time t, this is the point, and it makes an angle theta, which is the angular displacement. After time dt, small amount, this is my position, and this is another position vector, which makes an additional angle of d theta. That means with dt time, d theta is the additional angular displacement. So my omega becomes d theta by dt. And theta vector is actually, if you see, the motion is anti-clockwise. So theta vector is pointing outwards. Same is for the angular velocity. Great. So we understood where angular velocity comes into picture. Motion in a curved path, that is one. Great. How about angular frequency? First and foremost, angular frequency is related to any periodic phenomena. Any kind of periodic phenomena. It doesn't need to be motion. For example, if I talk about alternating current, how do we define alternating current? I is equal to I naught sine of omega t. I'm removing the phase part. So let's not talk of phase difference is not needed for the. So what is this omega? This omega is angular frequency. And when we say frequency, that means something which is periodic. Okay. And it depends on frequency. So frequency defines angular frequency. This angular displacement defines angular velocity. That is the reason I'm saying these are apples and oranges. You cannot compare. So that is one thing you need to be very clear. Okay. Now let's see where all this confusion is created. This confusion is created because of an equation of simple harmonic motion. What is the basic example of simple harmonic motion? Let's say there is a ball, and it's actually, this is, let's say, the maximum position on both sides. Okay, and it is moved by a very small angular displacement theta. Okay, so what is the equation of SHM? Equation of SHM says equal to theta. Now problem is this omega, which is equal to 2 pi f, is angular frequency, but this theta is angular displacement. And when we talk about angular displacement, this can also be written as alpha equal to minus omega square theta. and this is angular acceleration. Okay, so this omega square is not same as the angular velocity. Now, if you look at this, there is a motion in a curved path. Where is this curved path? This is the curved path. So there is definitely, this is back and forth happening. So this is definitely a motion in a curved path. That means there will be an omega, which is there will be an angular velocity. But this is not that angular velocity, it is angular frequency. That means if you say this alpha as, for example, d omega by dt equal to minus omega square by theta, this is wrong. This omega is angular velocity and this omega is angular frequency. Let me make this clear. For example, how do we understand what is the angular velocity? If we know the linear velocity and the point where it actually rotates or revolution is happening. So for example, the length of this string is L. So at this extreme position, what is the velocity? Velocity is 0. That means at this instant, angular velocity is 0. At this instant, velocity is maximum. So angular velocity is maximum. Again, here, angular velocity is 0. Now, if you look at this, that means angular velocity is changing. So is angular acceleration. Whereas, what is this omega square? This omega square is defined as G by L. And this is a constant value. Got it? Now, there are cases when the value of this angular frequency matches with the value of angular velocity. What is that case? Let's look into that. Let's say I have a circular motion, and this is a uniform circular motion. So if it's a uniform circular motion, that means at point A, point B, point C, and point D, the linear velocity that the body has, which is like this, is constant throughout. Because the linear velocity is constant throughout, the omega is also constant. So if omega is actually constant, that means it will take exactly omega, how much is will be the frequency of motion. That means the particle has to, if it starts from A, it has to come back to A. So that omega and the angular frequency of this circular motion exactly will be equal. Now, in similar case, when this is a non-uniform circular motion, let's say gravity is acting upon it, we know that the velocity here will be much higher compared to velocity at this point. That means velocity at every point is changing. So is the angular velocity. But still the angular frequency of this motion, that means it starts from A, come back to A, again starts from A, come back to A, the angular frequency is still the same. Okay, so never make that confusion of angular velocity with angular frequency. Don't even compare. They are conceptually different. Even if you have a motion which is going to fro, for example spring, okay, it's not a curved path, so you can define angular frequency there, but you cannot define angular velocity there. So what happens if the motion is for a spring between its mean position? Let's say this is the mean position. This is, these two are extreme positions. How do we define it? Acceleration is equal to minus omega square x, right? That we know about, right? So this omega square is what? This omega is equal to root k by m. Again a constant value. But here there is no curved path. So we cannot define angular velocity here or angular speed for the matter. Is it clear? If you have any doubt, please do post a comment. If you have anything to prove that okay, I am wrong, then do let me know in the comment section. Okay, thank you.